Okay, so now we have the surface z equals x squared minus y squared. This is a hyperboloid. We want to find a parameterization for the portion of the surface over the rectangle minus 1, 1 times 0, 1. Okay, so this is the graph of, the surface is the graph of a function. So the most straightforward way to do this is r of st is equal to s t s squared minus t squared. This is the most straightforward way, and this would give the whole hyperboloid, but we just want the portion over the given rectangle. So now we could either say d is equal to minus 1, 1 times 0, 1, or more explicitly, d is equal to s comma t, where s goes from minus 1 to 1, and t goes from 0 to 1. This would be one way to do it. Okay, but notice that we want the part that is inside the surface. We want a parameterization of this surface that lies inside the cylinder x squared plus y squared is equal to 25. Okay, so now this lets us know maybe we should be using cylindrical coordinates. So if we just get a parameterization for this in terms of cylindrical coordinates, is going to be r of theta comma s. Actually, I'm going to use orange for this part. R of theta s, well, the s or the x coordinate is s cosine theta, the y coordinate is s sine theta, and then the z coordinate is x squared minus y squared. So this is going to be s squared times cosine squared theta minus sine squared theta. Okay, and now we need to restrict the parameter domain. Well, we want the parameters to be inside, we want x and y to be inside the circle of radius 5 centered at the origin. That's what the thing about the cylinder says. We want the part of the surface that's inside the cylinder, x squared plus y squared is equal to 25. That only involves the x and y parameters. So this means we want x and y to be inside the circle of radius 5 centered at the origin. So for the parameter domain then, we want this theta s to satisfy the following. We want theta to go between 0 and 2 pi, and we want s to go between 0 and 5. Okay, so both the purple and the orange parameterizations are parameterizations for the hyperboloid. So the surface that we're parameterizing hasn't changed, but what has changed is the parameter domain. And notice that with the rectangular parameter domain, it made more sense to use rectangular or Cartesian coordinates, and with a more circular parameter domain, it made sense to use cylindrical coordinates. So this is what I'm saying. So which coordinate system you're going to use depends on both the thing that you're parameterizing and the parameter domain for the thing that you're parameterizing.